Okay, today we're looking at Elfmania. What an amazing game. Check out that line scrolling. So much going on in this game. So today we're going to try and work out at least partially how this all works using some new features in the ENGINE9000 Debugger. So there's a couple of ways we can sort of work out what's going on. We've got our debug window that we can use to disable stuff. So, the simple one first is like, what's a sprite, what's not a sprite, so we can turn sprites off. Okay, so interestingly, we've got an awesome HUD up here using sprites. And obviously the sprites are used for the far foreground holes, and maybe some other decorations, but yeah, so how do they do this with sprites? That's a lot of stuff to be doing sprites with. So one thing we've got in here is we've got this copper blocker. So I can basically I can disable copper from certain lines, and we can use this slider to disable, to work out where on the screen the copper actually is blocked. So if we move these sliders to disable the copper around the HUD, we can see that it's the copper that's driving these sprites. Next up, this amazing line scrolling. I mean, this stuff is awesome. Look at it. It's just beautiful. Floating platform, line scrolling. Well, okay, here we go. So I've implemented this new feature, which is a Blitter visualizer. So let's work out what's blitz and what's not. Let's get rid of sprites. No sprites. This Blitter visualizer was tricky to implement because on the Amiga, the Blitter, transforming between Blitter register operations and screen coordinates is no simple task. Unlike on the Mega Drive and the Neo Geo, where the geometry is easy to derive based on the registers, yeah, it's very tricky to go to screen coordinates from Blitter. But anyway, I think I've nailed it, so let's turn it on and see what happens. So we can see basically where we've got blitz. Now, I've just paused here and I'm doing a frame step, so you can see each cloud has a different blitz. Now, one thing you've got to understand is that we've got restore blitz as well as actual character blitz, so it can be a little confusing as to why there's sort of overlapping blitz, but probably that's restore and characters in the same frame. I've got this decay thing here, so we can sometimes if you want to, if there's a blitz that just happens one frame, you might miss it. So I've added a feature so that we can kind of essentially leave blitz on the screen for longer than they persist, so it's easier to visualize, or we can just sort of set it to one and see the immediate blitz. But what we can see from this though is that if we pause here, that at least the top half of this platform is using the Blitter. So that's interesting. We can disable lines, playfield scrolling with this if you're playing Con 1 scroll. So let's do that, see what sort of line scrolling action we've got as well. We'll just turn off the visualizer for a moment. Let's try and sort of do some scrolling, and we can sort of see some weird artifacts now that we don't have the scroll. So there's probably some scrolling going on down there, but not just scrolling. There's also some other stuff going on, because if we disabled the scrolling, we wouldn't have got those weird artifacts if there wasn't another factor at play. So what is it? What is it that's driving this? So probably bit plane shifts, so combined with line scrolling. So we know that line scrolling can always saw it. Let's see here. We know it's doing line scrolling on that area. But what else is it doing? So if we turn on this bitplane blocker. So this basically says we're going to stop allowing bitplanes to be reset between line, in this case 52 and 308. So if I drag this slider up, we'll see we can sort of change where that block takes effect. So see, at some point at this crossover line, we're resetting bitplane pointers as well. So bitplane pointer reset combined with line scrolling. Each line gives us this awesome sort of far foreground line scrolling effect. I mean, it looks magic, doesn't it? So yes, we've got line scrolling, we've got blitting here, but that's still a lot of work. So I wonder if there's any other tricks. So one other thing we can do is let's put everything back to normal. Get rid of the blitter visualization, get rid of the bitplane block. Let's just have a look at the bitplane usage. It's probably not going to be using the 7th or 6th bitplane. 5th, no. So, well, when I say 5th, I guess I really mean 4th, 0. Okay, so it definitely looks like we've got 32 colors, at least for the main characters, but not, interestingly, for the platform. So my guess is that this platform is got its palette devised in a way that they can blit. You can see here that they're doing line blitz for every line to get the line scrolling, but they're probably doing it in a way that is only 4-bit planes. I'm assuming it's so it's definitely 16 colors. Obviously, I mean, it's got 16 colors, but not 32. So we've got a split here in the way that they devise their palette, such that they can probably get away with only doing 4-bit plane blitz. I mean, maybe they've done it even more tricky so that they don't even have to do all 4-bit planes. Let's see. Yeah, it looks like all those 4-bit planes are used in that platform. So still pretty cool. Yeah. So long story short, looks like we've got repeating sprites for the HUD. We've got line by line 4-bit plane blitz for the top half of the platform, and then we've got line scrolling and bitplane pointer reset to achieve this bottom half of the platform, which is probably a lot less expensive than the blitz. I guess maybe the last thing I can show you is we've got this. That's the sort of easy point and click way to sort of do this kind of stuff. I find it really fun just to mess with this. But we do have another option, which is the logger. So this basically gives us for each frame, tells us every single write to any of the custom registers. We can filter these on sort of the register. So if we want to look at the color registers, for example, we can see which copper line they're being set at, whether it's the copper or the CPU that's doing the write. This is the address of the copper list, what the value is. You can see we've got decoders for each of the data fields combined with a different register. So if we look at something else like maybe what else have we got here? We could look at one of these sprite position registers. We've got decoders that sort of say what each of those fields mean. Whether they're right or not, you don't have to triple check those. But yeah, so we could have sort of checked out what what writes are going on in different parts of the screen to different registers to sort of back convert stuff as well, if we were sort of looking at it in a more technical way. One cool thing with this is if we have a CPU based write, which is going to be mainly the blitter, in a game, we can actually just click on one of these addresses and that'll set a breakpoint in the debugger. So we can instantly go there. Similarly, once I get the copper debugger moved across into this platform, we'll be able to put a breakpoint on the copper lines as well, so we can debug those copper addresses as well. Yeah, so that's probably something for another day though. But yeah, Elfmania, magic. See you next time.